Hello everyone! Today we're going to discuss about sheath folds in salt. So what is a sheath fold? Here we have a sheath fold. As you can see, the hinge line is highly curvy linear, making the fold look like a sheath, thus giving it its name. The apical angle here is usually less than 90 degrees. Another feature of the sheath fold is the eye pattern. There are three different types of eye patterns, and they are called the analogous eye, the bull's eye, and the cat's eye. To define each eye pattern, we have to first identify the ratio of the horizontal component and the vertical component of the inner and outer ellipse. Here we have the analogous eye fold, where the ratio of the outer ellipse is equals to the ratio of the inner ellipse. Next, we have the bull's eye fold, where the ratio of the inner ellipse is less than the ratio of the outer ellipse. Here you can see the inner ellipse is much more circular than the outer ellipse. Then we have the cat's eye fold, where the ratio of the inner ellipse is greater than the ratio of the outer ellipse. As you can see here, the inner ellipse is much more of an ellipsoid than the outer ellipse. Now that we know how sheath folds look like, let us explore how sheath folds are formed. Sheath folds in salt are often related to salt diapirs. They can be found in two different places, either on the surface in the salt glaciers or deep in earth in the source layer. Let us first look at the source layer. As the salt layer gets buried deeper and deeper into the ground, the sediments on top of the salt layer gets compacted and increase in density, while the salt layer, being crystals, retain the same density. Eventually, the salt layer will be of a lighter density than the surroundings and will want to rise up. Sooner or later, the salt will find a way up, and the salt diapir is formed. To facilitate the movement of salt towards the diapir, two flows are formed. First, a Poiseuille flow is formed. Then, as the sediments above becomes unstable, a Couette flow forms. As the salt flows towards the diapir, it encounters steps on the rigid bedrock above and below the salt layer. This creates folds that get progressively accentuated, so that sheath folds form as they flow closer to the diapir. Now let's move to the surface salt glacier. Salt glaciers, or namicures, form when salt diapirs protrude the Earth's surface and spread out by gravity. Here we have an example of a salt glacier. The raised bump in the center is the salt dome, where the salt diapir first pierced the Earth's surface. The surrounding gray bits is the salt glacier that spread out by gravity. Sheath fold formation in the salt glacier is similar to that of the source layer. The Earth's surface is filled with irregularities, from small uneven patches to larger domes and basins. As the salt glacier flows downslope, shear zones can be created. When the glacier flows across the irregularities, folds develop. If the region experiences higher strain over the obstacles, the folds will then develop into sheath folds. Here are some field examples of sheath folds from the Karmastage salt diapir. This is a bullseye pattern, and as you can see, the eye shape is quite obvious. Here is an asymmetric sheath fold from the same diapir. The tongue of the diapir is facing east. Sheath folds are very useful. The direction of the tongue can tell us the flow or strain direction, while the type of eye pattern can tell us about the type of strain involved. Cat's eye fold, for example, is commonly associated with simple and general shear, while bullseye fold is associated with constrictional shear. However, one should be careful, as bullseye fold can be found in regions with predominantly cat's eye folds. The dominant strain type in these regions will thus still be simple and general shear. In salts, 90% of the sheath folds have cat's eye patterns. And that's all I have for today. Hope you guys enjoyed this video.